Sometimes when you write a Java code in your Mule application and try to access it using invoke or invoke static module, you encounter some errors. And to solve those errors, you need to often export those packages in the class loader model loader descriptor in the mule-artifact.json. Well, why do we need to do that? That's because of class loading isolation present in Mule. So in this video, we'll learn about class loading isolation, why is it required, and how it works in the Mule runtime. So let's get started. Let's understand the class loading concept. Suppose I have a project dependency in my Mule project, and basically Mule is based on Java, so it follows the class loading principle to load all the classes. Now I have a dependency called Jackson core, and it has a version 2.11.1. I have another dependency which is of Mule API kit. It belongs to the API kit module, and it in turn uses Jackson, which has a different version. It's 2.10.0. Now, since all the Mule 4 projects are Maven based project, what happens in the absence of class loading isolation is that the transitive dependency of the API kit module would not be given preference. That is, the faster XML Jackson core in this case with version 2.10.0 will not be preferred. Instead, the project dependency will be given precedence. So the final version that the API kit module could utilize will be 2.11.1. So the problem over here is, suppose the existing dependency that the API kit module used, that is 2.10.0, would have some methods which are deprecated, or maybe they could have been removed in the updated version. So in such case, you might get unexpected errors. And to solve such problem, Mule has implemented class loading isolation. So let us understand what class loading isolation exactly is. So I have the same figure. I have two dependencies. What class loading isolation does is, it isolates both the dependency. So exactly what is happening, this dependency is being loaded by its own class loader, and this dependency is loaded by another class loader. So both of them uses different class loader, and that is the reason they both are isolated. So the benefit over here is, the API kit module can still use the Jackson core version 2.10.0, which is not being overridden by 2.11.1, and your project can still use 2.11.1. So this eliminates the reason behind inconsistent behavior. Now there is another problem over here. The problem is that suppose you have created a Java module or a Java class, and it has to be accessed by the invoke static. So invoke static will be part of another project dependency, and your Java application will be part of your complete project, right? If you create a project, there are group ID, artifact ID, so it will be part of that dependency. So both are different. Now if you want to access the classes that you created in your application, they won't be able to be accessed by the Java invoke module, because class loading isolation is present. So to access the common resources or packages, you need to explicitly inform Mule runtime to export them so that they are public and they can be accessed by any module. So this can be done in this way. You have a mule-artifact.json. What you have to do is, inside the class loader model loader descriptor, you add exported packages, and these are the packages that you want to make it public so that they can be accessed by any other module. So they won't be isolated, they will be kept public. And if we observe the exported resources, this can contain your log4j file or the flows that you want to share, some common flows that you have and you want to share those. You can keep it in exported resources. This is in case when you are using a mule application as a dependency in your project. So whenever you package it, your application, you can find it, the mule-artifact.json, inside the meta inf folder. So this is how the class loading isolation works. It isolates all the dependencies from other. And in Mule, all the connectors are part of a module, so they are being isolated with the help of class loader. Now let's see how exactly things work in the runtime. So I have a Mule runtime, and the Mule runtime is basically loaded by the Mule container system class loader. So it is responsible to load all the classes that are required for the Mule runtime to run and do its job. Then when you deploy an application, that application is nothing but an artifact, and that artifact is taken care by the mule-artifact class loader. Another thing, in Mule, all the dependencies, for example, all your connectors, it is HTTP connector, it's a database connector, all of them are known as modules, and modules are nothing but artifacts. So all the modules are loaded by their own class loader. So for example, if you have an HTTP connector, it is loaded by the artifact class loader. If we have a sockets connector module, it is again loaded by another instance of class loader. And if you have a Java module, it is again loaded by another instance of artifact class loader. So this promotes isolation, so all the transitive dependency, whatever are used by the connectors, remain intact and are not overridden. So in this way, the Mule runtime uses the class loading isolation to remove any unexpected behaviors. And in case if you want to expose your flows or the packages, Java packages, you just need to inform by adding those exported packages or exported resource values to the mule-artifact.json. Now let's understand a few more things about the class loading isolation using a Mule project. So for that, I have created a flow which has a listener, HTTP listener, and then it invokes a static method which is say hello. And for that I've created, so if we see, I have the class hello and it has a method, static method say hello. I created a Java class hello and it is having a static method which is say hello, and it returns hello world. And the same thing I am printing it inside a logger. So let's try to run this application and see if we get the desired response, that is hello world, in the log or not. So the application has started and I have triggered a request, and I can see the response hello world is printed in the logger. But now you might be wondering that I didn't even export any package in the class loader model loader descriptor. Despite of that, I am able to invoke the Java method, right? So let's just go back to the mule-artifact.json and let's see if I have added or not. So I can see I haven't added anything, right? And it belongs to class loading isolation demo mule-artifact.json, and it still works. So like in the slides we saw it should not work, right? But it's still working. So let's just go to the target folder and let's go to the meta-inf, and in meta-inf let's go to the mule-artifact.json. So this is created when we run the project, so it goes through the Maven like life cycle of build and finally it gets generated. And if we observe, the exported resources and exported packages are already populated. It's quite different than the one that we already have in this project, right? We only have a minimal artifact which is having min mule version, whereas this is full-fledged mule-artifact.json, which is having multiple properties. So the exported package com.mycompany was automatically added. And why did this happen? So if you previously worked on Mule 4, like in the beginning, you might have to manually add those export packages. But since our project is using a Mule Maven plugin, and that plugin has a version 3.3.5, so it was automatically able to understand what are the common packages, and it exported it by default. So that is the reason when we created a build, we automatically got these export packages. So you might observe this change from the Mule Maven plugin version, starting from, I guess, maybe 3.1.3 version. After that, they have included this feature in the Maven plugin to automatically add the exported packages. But you can still manually add the class loader model descriptor, and you can add the exported package. For example, if you do not want to make any package a public package, you want just to be utilized by that particular dependency, that particular module itself, so you can just mention those over here. And same is the case for flow. See, the class loading isolation demo flow has been exported, so you can manually specify it over here, and in that case it would go with the whatever definition which is present in mule-artifact.json. And if you do not specify, it will automatically take it by default. So that is the reason it was able to invoke the Java static method, and we are able to see the hello world response. Now that we understood how to export package, I have another use case. Like in the last videos, if you have been following my videos, we had a global error handler, right? And what if I want to export that global error handler as a jar and use it in my project? So I can do the same thing. So let's see that how we can do. Create a jar and use that jar in our class loading isolation demo. So I have this global error handler project imported already. If you are not aware of this project, you can watch my previous videos. The link would be in the description or at the top right corner of the screen. So in this global error handler, what we can do is we can go to the mule-artifact.json, or if you create a build, it automatically exports all the files. So we have to just create the build, and it will automatically export the file. So I've already created a build, and in target, if we observe, I have in meta-nf mule-artifact.json, it is exporting all the resources, my raml, common.xml, common.yaml, everything is being exported. What I am interested in, the common.xml, I want to import that. So let me just demonstrate this. You can either manually go to the mule-artifact.json and add only specific criteria that you want. So let's just add all the fields that we want explicitly. I don't want all of this to be exported. Instead, I want only a specific. So I'll copy this. Let's just copy the whole thing. Class loader model loader descriptor, and add it explicitly to mule-artifact.json. Not this one, but yeah, this one, which is not under the project target folder. Yeah. So I don't want anything else. I just want this common flow to be exported, because the common flow has the error handler, right? And yeah, that's it. I just want this to be exported. And let's just save this. And what I'll do is I'll do a Maven clean install so that it gets installed in my local Maven repository. I'll go to the source and do a Maven. Let's open a command prompt. And let's quickly do a Maven clean install. So the build has been completed successfully. Now let's go back to the studio and observe it says that the file has changed, right? The mule artifact in the target folder in meta-nf, it has changed. So let's click yes, and if we observe, whatever we mentioned in this mule-artifact.json in the application code has overridden, and it has honored that artifact.json. It didn't export all the resources or packages, but just exported the package that I wanted. So now that I have successfully installed this mule application in my local Maven repository, now it's time to import this package as a import this mule application as a dependency into our class loading isolation project. So let's go back to the class loading isolation demo, and let's open the pom.xml, and inside dependency let's add a new dependency. And okay, I have the dependency, and notice that we are getting an error in place of packaging. So it should not be a packaging because this is a dependency, so it has to be a classifier. Okay, classifier, and observe that this classifier is different from others. Those are mule plugin because those were connectors, or you can call them as module, whereas this is a mule application, so the classifier has to be a mule application. So let's click on control save, and we should get the so the dependency has been imported successfully, and you can validate it by going to the project libraries, and I can see demo 1.0.0 mule application jar. And now let's go back to the flow, and to import the flows of that particular project, what we can do is we can create an import, click on this and mention the file name. The file name was common.xml, right? The one that we exported. So let's click on OK, and let's just save this. And in that global error handler, if you remember, let's go to the common.xml. What else do we have? We have a global error handler, and apart from this we have a generate error response flow, right? So we should be able to access this flow in our new project, right? So let's just drag and drop a flow reference, and let's see if we get, so we are getting, right, generate error response. So we can call the generate error response, although we have not coded, but it has been imported as a global resource. Now what we can do is, I want to try out a global error handler. I want to reference that global error handler. So what I can do, I can go to global configuration and configuration properties, configuration, and then default error handler. I get the global error handler, right? And I can select OK, and I'm ready to use it. So any exception occurring, it will be taken care by the global error handler. Okay, and we are seeing some error. There was an error. Okay, let's see the console, and it says that the dependencies are not allowed unless their scope is provided. Okay, so it wants me to make the scope of my company.demo, that is a global error handler, to be provided, but if I give it provided, it won't be able to access it while running the application. So maybe I need to turn off the Mule Maven plugins validate phase. So doing that will help me to get rid of this error, because if I give provided, the jar won't be accessible while running the application. So I can't give it as provided. So instead what I'll do is, I'll go to the Maven Mule tools, and yeah, mule tools.maven, and over here what we can do is we can add execution, and give it ID as default validate and give the phase as none. So what it will do, it will skip the validate phase, because that validate phase of Mule Maven plugin is causing this issue. It's means by default it wants any Mule application dependency to have a scope as provided. So we are just trying to bypass that so that our application runs. Now let's try to run this and see if we are able to do a successful build. Looks like the build is going to be successful. Otherwise we would have instantly got some error. Yeah, it's building the zip. Okay, build was success. Now it will start the application. So the deployment failed again. Let's check the reason. It says couldn't find the resource config common.yaml neither in class path. So if you remember, when we created the global error handler, it was created using a Maven artifact, and it had all the files like config secure. So all these files were present over there. And since in artifact.json we explicitly said only export common.xml, the other things are not available publicly, are not accessible, instead isolated in this class loading isolation demo. Although if you see in the project libraries, you'll be able to see all those files config, but those are isolated, those are not accessible. So either you could have exported it over here, or instead what we can do now is we'll rather copy and paste the whole thing. I'll instead copy this config API, config secure, everything. I'll copy this and I'll paste this in the class loading isolation project. Or else if you are creating a global error handler in your project, you need not add all these things because it's just a flow, right? And so you need not add all these things, just add a flow and create a global error handler. But since in this there is already present, I had to make the change. Now what I can do is I'll have to run it again. Another thing to notice over here, even in that global error handler, we had mule environment properties set. So even in this case I had to set the mule environment property. If I go to run configuration, in environment I've set mule.env to dev. You can skip the test only if you are not referencing the global error handler downloaded from the GitHub repository which I've created. If you have your custom flow, you can skip all this, but since the global error handler has all these properties, I have to add those. So now that I've added everything, it should run. Let's try to see. So the application has been deployed successfully. Now let's try to hit a request. So when I have hit the request, the first logger printed hello world from the Java code, and then the second flow reference went to the actual flow and printed this error message. So if I go back to the global error handler and if I open common.xml, I can see the transform message, and the same has been printed, right? Code message type, and this logger caused it to be printed. So logger had additional statement status error, so that is the reason we are able to see code type message which is in the transform and the status as error which was added by the logger. And the same thing, the transform was sent back to the browser. Only thing, the status is not there because it is printed in the logger with ++ status as error. Now what we can do is, since we also have added a global error handler, we are referencing it through the global error handler project that has been imported. What we can do is we can try to simulate some error. What I'll do, I'll try to concat a null with the payload, and it should obviously fail. So let's try that out. So it's getting redeployed. Okay, the redeployment was successful, it seems. Now let's try to hit. Okay, we have got the response. So it was caught by the error handler, type was expression, and we got the message. So if you notice, we have got the exact payload that we were expecting, but in case if you try out this demo on your own, you'll have to go to the listener and change the response as payload, because by default it would be output application text, output text plain, and it will be error.description. So instead you might encounter the whole description like this, you call the function instead of this payload. But since I have changed it to payload, it's showing the exact payload which is being retrieved from the global error handler application. So this is how we can use the concepts of class loading, isolation, and then based on those we were able to share the flows of global error handler and export packages and use the Java methods. So I hope you would have found the video useful. Thanks for watching.